it felt like there was confusion around the ambiguous case and how many triangles and just what are we doing. So I found a nice applet on GeoGebra. I've given you the link that you could play around with it. All right, so here I have, so basically, I want to go through three situations before we even touch the ambiguous case. But the whole question around this is how many triangles can be formed given specific conditions. All right, the first one that we talked about was, so first of all of these conditions are SSA, meaning we know the lengths of two sides, and then we know the measurement of one angle that is non-contained. So it's not contained between these two sides. Angle C is contained, right? Where angle A is not contained. So we're starting off with an arm that is short. And as I press play, the distance doesn't change. But what we're noticing is there is no condition, there is no situation in which an actual triangle can be formed because this side A is just way too short to reach this horizontal line. Now, how did we choose that horizontal line? It's not by chance. It is because of the 30 degrees, right? If I were to angle this horizontal line up, then the 30 degrees would change. But I know that the blue line and this dotted line must make 30 degrees. So that's why the angle between these two lines can't change. And so that's why we're saying, okay, line A, well, I guess line B, the dotted line has to be horizontal. And so in this case, because line A does not reach line B, in this case, no triangles were formed. Okay. And then we came up with a measurement. Now I'm going to tell you about that measurement. Whoa. That measurement comes when, what I'm trying to do is get a vertical. All right, that's almost. Nope. Oh, I guess I could do that, right? 8. Okay. Perfect. There's, okay. So what I did is I took a guess and ended up that 8 is the right one. So the length of 8 for A gives us a perfect right triangle. Now let's see what happens when I swing this arm. Oh, it's not letting me swing? Okay, fine. How do I redo this? Oh, I suppose what it's saying is that it's not letting it swing because it is in touch with the horizontal line. Now, if I make it a little bit longer, 8.1, then it swings. And really, it's swinging from point to point until it reaches the horizontal line. Well, what if I make line A 7.9, so a little bit shorter? So it's swinging back and forth, trying to make contact with that horizontal line B, and it is not possible. So up until 7.99, 0 triangles are formed. It is impossible to form a triangle. Now, if I bring it back to the 8, what I see is, oh, this angle B is 90 degrees. This arm A will not swing because it has connected with the horizontal line. And so in this case, when this angle B1 is 90 degrees, we have only one triangle. So then we go back to our notes about what are the conditions under which we get a perfect right triangle. And that's this first situation where we have a perfect right triangle. We make one triangle. And how do we do that? Well, we did a bit of math and we found that A has to equal to C times sine of A. Okay, that is the only way for us to have one right triangle. So if I'm checking how many triangles, I check if the non-contained side equals to this side times sine of the uncontained angle. That's how you know if there's one triangle. Okay, so that's what we're checking. We're taking the side that is swingable, right? The second side, and we're checking, does it equal to this side times sine A? Now, if it is less than, if it's shorter, that means we are in this situation where we have no triangles formed. So if side A is too short, you have no triangles. Okay? If it's perfectly the right size, we have one triangle. And then if it is longer, we've got two different situations. So let's go back to, so if it is a little bit longer, let's say 9, we get into ambiguous case, okay, where the arm can swing and it can make contact with line B twice. But what we said, oh shoot, sorry, I'm not sharing it. Right, so as arm A swings, it makes contact with line B twice. But then we said, wait a second. There is a situation in which you will have one triangle, and that is when A is longer than C. So let's see what we mean by that. So C is 16. So let's make A 16 point, or let's just make it 20, okay? So when it is 20, okay, we see that this arm will only come in touch with B this once. Now, someone asked a question, well, can't we extend B backwards? And the answer is no, because we said that angle A is 30 degrees, right? In theory, you could make another triangle, but that would make this interior angle 150, right? So in this case, we only have one triangle formed, as you can see. Now, what happens when side A is, so let's go back to our note. What are we talking about? We are talking about the situation where line A is longer than line C. When A is longer than C, i.e. when the side that is not touching the given angle, when it's longer than the side that is touching the angle, then we have one triangle. All right, so we have talked about one triangle as a right triangle, 0 triangles when A is too short, and 1 triangle when A is longer than C. So those are 3 situations. Now, let's look at the ambiguous case situation. Now, we're going to talk about, first of all, I want to see when A is, okay, let's make it 15.9. No, let's make it 11. Okay, so basically what we're saying is between 8 and 16, we're going to have situations where 2 triangles are formed. So the first triangle is this small dark blue obtuse triangle, right? And I say obtuse because as you can see, this angle, angle B2 is obtuse. The second triangle is not this light blue one. The second triangle that is formed must include this angle A. So it's angle A, side B, side A, all the way back. All right. This light blue triangle that we're talking about, that you see here, this is that isosceles triangle that we talked about that is formed when there is an ambiguous case. Okay? All right, so that is a review of how to know how many triangles there are. Okay, let's stop.